So Venn diagrams are pretty prominent, and you need to know how to use them to help you answer questions. The set part of this is more notational stuff. So a set is simply a collection of things, just a list of things that satisfy a criteria. So in exercise 1, they define set A as the collection of all integers greater than 0 and less than 10. So part A is to list those out. So greater than 0, less than 10 would be 1 through 9. So I listed all of the elements, and so that's the set A. Set B is the collection of prime numbers greater than 0 and less than 20. Prime numbers. What's the first prime number greater than 0? 2. Then 3, 5, 7, not 9. Definitely no more even numbers, right? 11, 13, not 15, 17, and 19. Okay? Let's pretend the entire population of numbers we're looking at is anything between 0 and 20. How many numbers are between 0 and 20? When I say between 0 and 20, does that include 0 and 20? No. So you're talking about integers 1 through 19, which is 19, right? So there's 19, I'll put in parentheses 1 through 19. So there's 19 items total. Set A is defining, obviously the way we did in B, so forth. So we're going to create a Venn diagram to not really display the two sets, but to display the number of items in each set. And I'm going to show you how a Venn diagram works. First of all, raise your hand if you've heard of a Venn diagram. What do you think of, Maggie, when you think of a Venn diagram? Between two. Right, the two different things in our case are set A and set B. And there's going to be some commonality, and then there's going to be some differences. And that comes in the form of two circles that overlap each other. So the circle on the left I'm going to call set A, and the circle on the right I'm going to call set B. Now, we're just going to fill in numbers. Like, how many numbers are in set A? 9. So within circle A, there's really two sections, right? There's a section for just A, and there's a section within A that also is in B. Okay? Those two values have to add up to the total number of items in set A. But is it 1 and 8? Is it 0 and 9? Is it 2 and 7? So we'll talk about that. And then set B has 1, 2, 3, 4, 5, 6, 7, 8 numbers. So in the circle for set B, these two need to add up to 8 elements. Okay, how many elements are in each set? And the best way to start Venn diagrams, and by the way, put it inside a square because there's an option for neither as well, something that doesn't fall in either category. The best place to start with Venn diagrams is always in the middle. How many items are in both? How many of our numbers fall in both categories? Andrew? 4 numbers. A 2, a 3, a 5, and a 7. So 4 of them are in both. Good. How many are in just A, but not in B? How many does that leave us that are in set A only? 5. So do you see how those two numbers in circle A add up to 9? Because there are 9 elements in set A. And how many numbers are in B without being in A? 4. The 11, 13, 17, and 19. So if you add up your B circle, how many are in there total? 8. And if you count 1, 2, 3, 4, 5, 6, 7, 8, that's how many elements are accounted for. Okay? Now, I gave you this. We're dealing with 19 numbers total, the numbers 1 through 19. So far, these add up to 13. We've got 13 numbers accounted for, which means how many are not accounted for? 6, meaning those 6 are in neither category. What numbers are those? 18, 16, 15, 14, 12, and 10. Those were the 6 that didn't fall in either category. Okay? So a few notational things. Probability-wise. The probability of picking a number that's just in A, or not just in A, but probability of picking something that falls in set A. There's 9 out of a total of 19. Yes? If you look at your Venn diagram, in A there are 9 out of a total 19. So that would be 9 out of 19. How about the probability of B? Oh, Evan, what do you think? Probability of B? 8 out of 19. Very good. Now, a couple new symbols. A, and then this upside down U. That means and. It's like an upside down U. So I'll write and. What's the probability that we pick something that's in both A and B? Kaylee McCadden. 4 out of 19. A and B. And is the overlapping section. So that's 4 out of 19. Okay, there's another symbol that's a U. That means or. What's the probability that we pick something out that's in A or B? What do you think? J-Touch. What do you think? Probability of picking a number that's in A or B? Which of these numbers did you add to get 9? This 5 and that 4. Why didn't you, if something were in both categories and someone asked you the yes or no question, is that number in A or B? Would you say yes or no? Yeah, right? Just because it's in both doesn't mean it's not in one or the other. Of course it's in one or the other if it's in both, right? So you actually want to add all of these together. Does that make sense? So the probability of picking a number that's in that's in A or B would be 13 out of 19. If you listed all 19 numbers, 13 out of 19 of them will be in one of our categories. Some of them have the extra blessing that they're in both. So what? Okay? You're still in one or the other. Okay? Couple other things I want to show you. Probability of being in A and not being in B. There's a new notation for you. It's like the not sign is like a little squiggly mark. So this would be, what is your probability of being in set A and not being in B? So probability of being only in A, in other words. Kirsten, what do you think? 5 out of 19, yep. And we could do the similar thing for B. What's the probability of being in set B but not in set A? Connor, what do you think there? B but not A. 4 out of 19. What am I forgetting? What is the probability of being in not A and not B? 6 out of 19. Very good. Did I hit all the ones I wanted to hit? So just some notations to be on the lookout for. But all the ways that we can be asked probabilities with Venn diagrams. So exercise 2, here's a real life example. In a contract negotiation between a local government agency and its workers, it is estimated that there's a 50% chance that an agreement will be reached on the salaries of workers. Estimated there's a 70% chance that there will be an agreement on the insurance benefits. So we're trying to decide if we agree on salaries or insurance benefits or both or neither. Okay? The difference with this one though is that you're not given hardcore numbers, you're given percentages. What should your percentages all add up to? 100%, right? So when I make my Venn diagram, I'm going to have my left circle is going to be for salaries. My right circle is going to be for insurance. And then obviously you could come to an agreement on neither, and that would go outside your box. But all of these percentages should add up to 100%. So we're going to have this part of the circle, if you look up at the board, is for just reaching an agreement on salaries but not insurance. This part of the insurance circle is for just insurance agreement but not being able to come to an agreement on salaries. If you're in the middle, you're coming to an agreement on both, right? And if you're outside here, you're coming to an agreement on nothing. And they should add up to 100%. So when they tell you that there's a 50% chance of making an agreement on salaries, we don't know how to break up that 50. We know that this number and this number need to add up to 50 total in the salary circle, but we don't know how that's split. Could be 10 and 40, could be 20 and 30, we don't know. But these two should add up to 50. There's a 70% chance of an insurance agreement, so this one and this one in the insurance circle should add up to 70, but again, I don't know how that's going to be split. And then they tell me there's a 20% chance that no agreement will be reached. So that for sure I can put out here. 20% can go on the outside. Which means, what do these three have to add up to? 80. So there's a couple ways we can think about this. And don't write this down, but I'm just thinking out loud here because you're going to eventually plug in numbers. We know that x plus y plus z has to add up to 80%. Yes? And I know that x plus y has to add up to what? Salaries has to add up to 50. And y plus z has to add up to 70. So I could do a system of equations in 3 variables, which we've done before. Okay? I'm not going to do that here because there is another logical way of thinking about it. If I just look at the salary circle, which is supposed to be 50, and the insurance circle, which is supposed to be 70, what are they already adding up to? 120. But we know that they're supposed to be only adding up to 80, yes? So they already add up to 120. They're only supposed to add up to 80. So how much are they over 40? There's your both category. That got double counted. That's why it's over. It got counted in the salary circle, and it got counted in the insurance circle. That's why we're over our target number by 40. So y is going to be 40. Again, starting that Venn diagram, thinking from inside out is going to help you. Now that you know salaries is supposed to add up to 50 total, what's that x going to be? Jordan? 10. And Andy, what's this insurance number going to be? 30, because we're supposed to be 70 total. And then double check those numbers. Do we have our 50 for salaries? Yes. Do we have our 70 for insurance? Yes. Do we have overall adding up to a total of 100? Yes. So you can think through that without doing that system in 3 variables. Okay, but when you think, there's less work to be shown and a little bit tougher, to be honest. But are there any follow-up questions on that? Because that's kind of the type of question. That's actually from a Regents. So that's kind of the extent to which we'll have to think through it. Okay. Subset, it's just a vocab word. A subset is a smaller set, usually within a larger set. So this asks us to write a subset for set A. A was the integers 1 through 9. So a subset, we'll do S, could be the odd integers between 0 and 10, which would be 1, 3, 5, 7, and 9. So that's a subset of A. And then another vocab word, complements. Things are complements when it either has to go one way or the other. So you could say odd integers between 0 and 10 versus even integers between 0 and 10. Those would be complements of each other that would together make the entire set A. In light of flipping a coin, complementary events are flipping a tails versus flipping a heads. You have to be one or the other. And that's all complements means. It's kind of the one event and then anything else would go into the other. So if you flip to the back, we'll do a little more with complements. This is consider rolling a single 6-sided die and recording the result. So A is the event of rolling a number greater than 4. So what would that be? 5 and 6. B is going to be the complement of that. So what is the complement of rolling a number greater than 4? What is the rest of the possible things you could roll? 1, 2, 3, or 4. Correct. In verbal language, that would be anything that's less than or equal to 4. Okay, those are complementary events. Because when you roll the die, you're either in one category or the other. You're not in both, and you're not in between. Okay? So draw a Venn diagram that illustrates the sample space. If events are complementary, there's 0 overlap. No overlap. And also, there's 0 that are in neither. You're either in only one or only the other. So A has 2 elements and B has 4. There's no way to be both and there's no way to be neither if you're in complementary events. So the probability of A is what? Mason? What's the probability of rolling something that's in set A? 2/6. Because it's a 6-sided die. So there's 6 possible outcomes, and 2 of them are in set A. So your probability of rolling something in set A is 2/6. Mason, does that make sense? Okay. Well, now that I explained it, does it make sense? Oh, okay. Well, I'll give you a second then. Does anybody else have any questions on that? Or share with me if anything's confusing about it? So you're rolling a die. There are 6 possible outcomes. And of those 6 outcomes, how many of them are in set A? 2 out of the 6. Does that make sense? Now, Mason? Okay. And then in B, again, there's 6 outcomes when you roll a die. You can get a 1, a 2, a 3, a 4, a 5, or a 6. So there's 6 possible things that will show up. Of those 6, how many are in set B? 4 of them. So this simplifies to 1/3, and this one simplifies to 2/3. What is true of the sum of those probabilities? 1. When events are complements, their individual probabilities always have to add up to 1. Because there's a 100% chance you'll get one or the other. Okay? Because there's no neither category. So exercise 4, just again hitting home this complement idea. If the probability I will draw a red marble is 3/17, what's the probability that I won't draw a red marble? 14 out of 17. It's the rest. If 3 out of the 17 marbles are red, the other 14 are not red, right? It's pretty basic. Once you get the hang of it. And then if on the news you hear that the probability that it's going to rain tomorrow, the chance of rain is 20%, what's the chance that it won't rain? 80. Okay, so whether it's in a fraction form, getting it to add up to 1, or if it's in a percentage form, getting it to add up to 100%. Any questions on that? Okay. I want to jump down to this last one for sure. We'll probably get to all of this, but I definitely want to talk about this one. Take a minute on your own and think about that. Again, this is a Regents question, and if you just read it to the average person, it's tricky. It's a brain teaser. If you read it to someone in Algebra 2 and you see it on a Regents exam, you should think Venn diagram. Okay? The average person on the street's not going to think, oh, no problem, I'm going to make a Venn diagram. But because you're going to be used to this type of question, you need to think Venn diagram because it's going to make your life way easier. The two categories are choir and then ballet. 9 have been in a choir, but again, I don't know how that 9 gets split. I just know that the choir circle needs to add up to 9. Ballet 10, I don't know how it's split, but here's the key. They tell you how many have been in both, and that really is the foundation for your Venn diagram. So if 5 have been in both, now my choir total needing to be 9 is pretty easy to figure out. I've got 5 already accounted for, so the remaining 4 to get me to my total of 9 is just choir. And my ballet total needs to be 10. 5 are already accounted for, so my other 5 are just ballet. So then we can answer the question. How many people have been in a choir but not in ballet? 4. 4 in a choir but not ballet. Does that make sense? Raise your hand if you got that. Good, good, good. Okay, 4. Does anybody have any questions on that one? And then the previous one here, 2 4-sided die are rolled, and the number on each is noted. So the first, well, we'll do a tree diagram. The first time you roll it, you're going to get a 1, a 2, a 3, or a 4. When you roll a second one, does what happened on the first one affect what's going to happen on the second one? Even if I was rolling the same die, these are independent events, right? It's not like I'm more or less likely to get a 1 the second time if I already got a 1 the first time. So every one of these has 4 additional branches for the second roll. So how many are there going to be total? 16. Options on the first roll are 4 times 4 on the second one is 16. And so what is the probability that you don't get 2 of the same number? Well, this is where complements will be helpful. What is the probability that you do get 2 of the same number? 4 out of 16 is your probability of getting the same number twice, which means what's the probability of not getting the same number twice? The rest, 12 out of 16. Very good. Which is 3/4. What's funny about that question? Does anybody have very